All right. Well, good afternoon. Thank you for attending our lectures. Today is lecture 5. I'm very happy to see all of you here, almost everyone. So before I start, homework number 2 is due today, midnight. Okay. Now, if you still have questions about homework number 2, you're welcome to stay behind after the lecture and we can talk about it. Okay, we can talk about it. Now, before I start again, I want to just quickly review what we have done before, right, so far. Now, we have talked about the basic concrete and steel properties. And from there, we moved on to talk about the cracking and all the other nice attributes of the concrete. And then we did analysis for a singular reinforced section for a single layer, then afterwards double layer or multiple layers for a singular reinforced section. Then we went down, talk about how to do analysis for doubly reinforced section. That means there is a compressive reinforcement added as well. So analysis for both beams are almost identical, but the difference is that for doubly reinforced section, you need to change the compressor zone basically by guessing it. You make a table for it and you guess it. Okay, so that's the main difference between doubly reinforced section and simply singly reinforced section. Okay, now today we're going to talk about the bar details. Essentially, is talk about how we place the reinforcing bars in the section. And after this, we're going to finally talk about the design for singular reinforced section and reinforced. Okay. Now, for the first exam, why am I nagging you all about it? Because for the first exam, it's going to cover singly reinforced beam and doubly reinforced beam analysis and design for singly reinforced section. Okay, so that's what the exam will most likely cover. So if you have time, I would say now is a good time to start reviewing the materials. Okay, again, you may have questions about the exam time. It will be on the
When is our
Thursday,
exam?
and specifically, I don't really know the time yet. I need to confirm with the registrar office. But I would say that
When
by
is the
early
exam?
next week, we'll know exactly the uh, time for the exam. And please mute your microphone if you have no questions, because this will help me clear on the background noise. Thank you. And so we will let you know the exam time, and probably it's going to be online. And for the online exam, it's going to be open note, so you have access to everything. However, the exam 3 hours long, so I doubt that the open notes will help you a whole lot. Okay. All right. So before I start, any questions so far? Any quick burning issue you have to solve right now?
You said that you haven't determined the day of the exam, correct?
The exam will be on Thursday, like this time. It's just that I don't know the exact date yet. I need to confirm that with the registrar office. But the exam will be held on Thursday, like this time, 1 to 4 o'clock usually.
You
Okay.
talking about next Thursday?
I'm sorry.
You talking about next Thursday?
I just said I don't know yet. I'll let you
Oh,
know
okay.
early next week because I
All right,
need to
my bad.
confirm that with no worries. I need to confirm that with the registrar office.
Okay,
Okay. Yeah.
thank you.
No problem. Anything else? Any burning issues? Anything that you need to get out right now? Okay. All right. So I assume you're good. If you're not good, you can stay behind and we can talk about
Professor?
it. Yes, sir.
Yeah, so I'm in San Diego, California right now, and this class was advertised as online asynchronous. So if we're gonna have in-person stuff, like I can't attend. And
Well, I don't
how's
think
that?
we'll have in-person exam for the first exam for sure now. It's going to be online. So in the sense is that we'll leave the homework to you. We'll open up the we'll leave the exam to you. We open up the exam during the hours that you have access to, and you turn them in the format of PDF.
Sure, but I'm saying throughout the entire semester, like all my classes I chose to take online asynchronous, which meant, it's online. It wasn't intended to have in-person classes.
Well, we won't have any in-person classes. I'm
Well,
just saying,
same with the exam as well. I know I had a professor last semester who everything was online except for the exams, which was fine because I was in Raleigh at the time. But now I'm in the Navy on orders in San Diego, and I can't just be like, oh, I've got an exam. I got to just go to Raleigh and take it.
I
You know what I
understand.
mean?
I understand. So let me say this. I don't think you need to be physically here to take the exam because the course is advertised as asynchronous, but exact format exam can vary. We have tried two formats before. One is this posting online and you have access to it throughout and you can finish and upload. The other is a take home, meaning that we'll give you the exam and leave that for a period of time. You complete that and then you turn them in. So the format can change. I'm not sure exactly which format we're going to go yet, but for the first exam, most likely we're going to go with the first format. Is that I'm going to make several versions of the exam. Everybody will have a different version and you have access to the exam 1 o'clock to 4 o'clock on the Thursday. Whether it's next week or the week after, I'll let you know early next week, but that's most likely going to be the format exam.
Okay, awesome. Thank you.
All right, no problem. Okay, so like I said, if you have any concerns of not being the physically in Rolla, don't worry about it. But the exam time is synchronous. That means you need to actually save that time on the calendar so you have time to finish exam. Okay, for the first exam. Okay, all right. Any other question?
I have a question. Will you issue a study guide before, or just go based on what you said to that will be in the exam?
I'm not sure I understand the word of study guide. What I will do is that I will let you know. Well, I will do a review with you. But right now, as I said, the content of the exam that we'll cover will include the basic properties of concrete and steel, and the analysis of singularly reinforced section and doubly reinforced section, and the design for singularly reinforced section. And that's much of the exam will cover.
Okay, thank you.
No problem. Yeah. Anything else? Anything? Any other questions for me?
I had a question concerning last lecture.
Yes, sir. Kyle.
At the very end, you had given a second quiz. I did not get the date that that second quiz was due.
If you go online and actually if you follow the lecture on the recorded video, I showed you that the quiz should have a specific due date on the canvas. If it's not there, maybe when I click on it, it did not click. Usually every quiz and exam is a 1 week deadline, 1 week due time.
Okay, I hadn't seen that, but I'll check again. Thank you.
Yeah, no problem. Yeah. Anything else, guys? Anything? Those are very good questions. We're doing this not in phase. So I like this question a lot, so it can clarify a lot of issues. So if you have any question, now's the time. Anything? Okay. All right. Well, I'm not saying, hold on 1 second. Okay. Let me see, there's an urgent issue here. Okay. Sorry, guys. Give me one. Sorry, folks, just give me like 20 seconds, all right? Sorry about this. All right, sorry about that, folks. It was just some urgent things. I just have to reply. All right, so now without further ado, let's take a look at the notes, okay? So first of all, let me open it up. And every time I pray, there's no technical issue, okay? So let's see, great, okay. All right, so lecture 5, okay? So now today we're going to talk about the section dimension, meaning the width and height of the section, and how do we determine that, as long as well as the bar detailing. Okay, meaning what is the location of the bars, how we arrange the bars into the section. Okay, very critical information. And if you don't have a coffee with you, I suggest you get one. while watching because it's going to be a little bit tedious today, okay? So first objective of the lecture is to understand how to select, the section size. Okay, meaning what is the height, what is the width, so on and so forth. And objective two is we need to know how to design bar spacing. How far we put the bars together, how many bars we put in section, so on and so forth. Okay, all right, so now let's take a look at the first thing is understand how to select the section size. Usually in analysis, the section is given, isn't it? We tell you the width, we tell you the height, and you go figure out the capacity. That's what we did before, isn't it? But there's a burning question. How do you know this has to be this tall, this wide, right? So especially, how do we know to determine the height? The why width, you say, Bob, why width? Width is easy, right? Because you need to know the supporting structure to determine the width. For instance, if I have a bridge and that is part of the bridge pier, okay, and this is the column or bridge pier, and I want to put a beam on it, right? And naturally, you want to put a supporting pad, which is like a neoprene pad on it, and then you put a beam. So when you put a beam, of course, you want it to be matching with the size of the column, right? With the size of the columns. Hence, the width of the pier usually determines the width of the beam. Okay, so that is easy. That is easy, right? Not too hard. The real challenging part is actually the height. The real challenging part is actually the height. How do we determine the height? How do we determine the height? Again, I'm going to use this picture here to show you that, for example, now this is just the cross section cut. You know that it's extended to the other end of it, and then the other end of it also have the support right here, for example, and there's a column underneath it right here, right? So to select the section height, we rely on the deflection control, okay? So that's why right here by deflection, meaning that I need to have a section that rigid enough that it won't sag too much. It won't sag too much, okay? So the delta maximum, in this case is the middle span, should be a function of the clear span or center to center span length, L. Okay, and from structure analysis, you know that delta max in this case should equal to a coefficient, let's call it C here, and omega, which is the loading on top of it, right? Dead load plus live load, whatnot, right? And omega, L to the power of 4, L means the span length, and divided by EI. E means Young's modulus, I means moment of inertia, right? So where are the edges in this equation, right? So you know that I, for rectangular section in this case, is 1/12 BH cubed. Okay, so if I further roll out this equation, so delta max equal to a C omega L to the power of 4 divided by 1/12 EBH cubed. Okay, EBH cubed. Okay, so I'm gonna play some manipulation here, right? So what I'm going to do is I'm going to move the L on the left hand side. So this will be the L, move one L on the left hand side, and right hand side it becomes C multiplied by 12 divided by EB, okay? And there's a omega here, okay? And now I have L over H to the cube, L over H to the cube. Right? So what I'm trying to say that now you see that the deflection of the member over the span length, that is a ratio, right? That is actually the function of the length over the section height over to the power of 3, over to the power of 3. So that means the higher L over H ratio is, the higher deflection I have. So I need to constrain it. I don't want it to be too big. I don't want it to be too big, nor I don't want to be too small. Why? If I get it too small, it becomes a stocky section. That means like a very short length but very deep beam, right? That is cost of waste of materials and extra cost in construction, isn't it? So not too short, not too long. Therefore, okay, a minimum okay, a minimum value, okay, is required for L over H, right? So that means L over H should have a range, okay? This is the mathematical symbol means belongs to, okay? Belongs to. And then the range bracket means bigger and equal to L over 18, okay? L over 18 and L over 12. L over 12, okay? L over 12. All right, so that means I have a minimum height of the section, minimum height of the section. As a matter of fact, you don't have to think too much because ACI already thought out for us. And you can find this from ACI table 9.3.1.1. Okay, all right. And it says that members not supporting partitions. Okay, you can find a definition of that in the code, or other construction that are likely to be damaged by deflection. Okay, in short, it's basically saying if it's deflection control, okay, deflection control. So H, let me, sorry, this should be H should be between L over 18 or L over 12. That is the range for the height of the section, okay? Range for the height of the section. All right, so that's how we determine the height. How we determine height, basically by the span length, So that is not too hard, is it? Now, the second one is the bar detailing. Okay, so now if I know the section by width, because that's determined by the supporting members, height, that is determined by the span length. I have a section. I need to know how to put my bars in it. So bar spacing and correspondingly concrete cover. Okay, and you can find this in ACI. 25.2.1. Okay, 25.2.1. And if you have the textbook, and this is in the textbook, chapter 5, section 3. Okay, chapter 5, section 3. All right, so before I go into it, right, there are several reasons why we provide spacing and concrete cover. Okay, why we provide spacing concrete. So why spacing and cover? This question, right? Why do we need to provide that? There are the following reasons. First, most important thing for us is corrosion. If the concrete cover is so thin, the water goes into it and eat the steel, react into corrosion and hurt the structure. No good, right? And the second is that we have a fire protection. If the concrete is so thin, it can burn to crisps and the spalls, and the reinforcement exposes, which is bad. Okay. Now the second reason is bonding. Okay, why is that? Imagine I have a bar right here, okay, and this bar will be transferring stresses to the adjacent concrete, And if you try to pull the bar out, essentially you introduce the circumferential stresses in the concrete neighboring, and it will cause cracks just like that. Okay, now if you put bars too close, it can easily crack through the spacing between bars and cause the loss of bonding. All right, so bonding is important. That's why we need to provide spacing. Okay, we need to provide spacing. Now the third issue is that we need to have, sorry, let me go back to the color. Third issue is that we need to have for ease of construction. Okay, why is that? Because for example, if I have bars here, right, I want to pour concrete in it, I need to make sure that I have enough spacing between the bars. I have to have enough spacing between the bars to allow my aggregates going through, right? If I don't have any aggregates, you end up with just cement underneath the bar, so they'll be very weak. Okay, and last but not least is wear and tear. and tear. Okay, what is happening is that if you go under the concrete bridges, right, underneath the concrete bridges, you see a lot of spalling, right? Partially due to the corrosion, partially due to the erosion and shrinkage on the surface. So you need to have concrete cover to preserve your bars, Okay, now these are the reasons why we need to provide concrete cover and bar spacing. And like I said again, smart of you will realize that this will happen in the first exam, right? In first exam. I realize I keep saying it, but a lot of you just mute it and watch my notes, so might as well just write down it so you know, okay? This way will show up in the first exam, okay? Remember this. All right. Okay, so now we know the philosophy behind the reason why we need to know the specific, right? Before we go into specifics, right? A lot of preparations. We need to take a look at some terminologies, right? So let me move this thing down here again. Just say terminologies, right? Terminologies. There are some names we need to learn. Okay. Now take a look at the corner of the concrete. Corner of the concrete. That's the edge. Okay. So imagine I start to put reinforcement in it. Okay. So first thing first, what you will see from outside in is the stirrups. Okay. It's the stirrups. Shear reinforcement, transverse reinforcement. And the stirrups goes just like this and have a curvature. Okay, have a curvature. And I don't want anybody to draw a straight angle here. Okay. If you draw a straight angle, 0 point for you. Okay. So it's always a curvature. All right. Now to put the bars, so naturally you would think I would put bar here. I would put one bar here. Okay, and pay attention, right? When I draw the bars, I did not fit exactly on the corner. I did not fit exactly the corner. Okay, it's somewhere on the bottom of the stirrups. Okay, so that's one bar. That's one bar. All right, and of course this is in tangential contact. Tangential contact. Okay, now I have to put another bar adjacent to it. So there's another bar, and forgive me if it doesn't look like a spherical. Okay, trying my best here. Okay. And that's more like elliptical, spherical, but that's another bar, right, beside it. Okay, now on top of the stirrups, this line is not looking good, so let me just draw it more smoothly. On top of the stirrups, I have another bar. Which is in line with the bottom bar here, in line with the bottom bar here. And of course, right, I have another bar right here. Sometimes I don't, sometimes I do, okay? So let me just draw 3 bars, right? So at this settings, there are some names, right? First of all, of course, you know this on the side of it, okay? We call this clear cover, okay? Or CC, right? Clear cover means there's nothing, just pure concrete. And at the bottom of it, also here, we call it clear cover, okay? Clear cover, okay? Now, in addition, there's also a pure spacing between the edge of the bar to the edge of the bar, and this is so-called clear cover as well. Okay, but let me just call it clear spacing since it's between bars. Okay, clear spacing since it's between bars. Now this is clear spacing in the horizontal direction. Okay, now I also have a clear spacing between vertical direction. Let me just put it here. And yes, you guessed it right, they're different. Okay, they're different. The requirements on these are different. Okay, now these are spacings. These are spacings. All right, now first thing is that we know that the clear spacing normally has to be 1.5 inch. Okay, and this is under normal exposure. What do you mean by normal exposure? I mean not harsh winter, just on the outside of the structures. Okay, so under this condition, we normally keep the clear cover to be 1.5 inch. Now the other CS, right? We call it, there are 2 separate, right? So for the horizontal one, for horizontal spacing, right? The requirement is that it has to be larger or largest, right? Largest of the 3. What are the 3? First, bar diameter. Okay, bar diameter, we call it dB, of course. And then 1 inch, right? 1 inch. And the other is 1.33 times of diameter, diameter of aggregates. Okay, Now, if you wonder where this 1.33 coming from, is always 4/3, actually 4/3, okay? 4/3 diag, diameter of aggregates, okay? Now that is for the horizontal requirement. For the vertical, things are slightly different. For the vertical, slightly different. It just has to satisfy the larger of 2, right? One is 4/3 diag, diameter of the aggregates, diag, okay? And then 1 inch. All right. Okay. All right. So that's the spacing requirement. That's the clear cover requirement. See, it's not bad, right? It's easy to remember. But there are also other requirements. If I want to put bars in, right? For example, if I want to put 5 bars in a section, right? So I take a look at the section. I say, you know what? I'm going to put 5 bars in. So first thing, I need to put the 3 bars, because it's 5, right? I want to put the higher number of bars in the bottom row here. Now, I can put the bars like this to make it a 5, right? It looks pretty good, pretty neat, right? All spaced out and everything, right? Or I can put the bars like this, pretty odd. Make some perfectionist uncomfortable, right? On the edges, line up on the sidebars. So which one is right? The answer is this fellow here. Now, this is not right. Okay, you say, but why? I provide enough spacing. Isn't that enough? It's not enough because I will have stirrups. Okay, I'll have stirrups. And it is easy to tie, actually wire tie the bars to the stirrups like this. If I put the stirrups like this, it's going to be very hard to put the bars. What you end up have to do is you have to put a support bars. Then here is a lack of support, right? But you may ask, but what if I have bars like this, right? Bars like this. Then yes, you can put the ties here, and let the bars resting on it and use ties. Actually, there are zip tie guns, and your hand can also do the hand tying. It can tie like that. Okay, so always start from outside in. Okay, start from outside in. That's very important. Start from outside in. Okay, not inside out. That's how you put bars. Okay, outside in. Okay, all right. So these are the ground rules for making the bars, for putting the bars. But not bad, not bad. But now I want to talk about specifics, right? Talk about specifics. That means I want the calculations. So here I want to give an example, right? Determine beam width and depth. Okay, and now you start asking questions of why beam width. You told me already it's got to be determined by the width of the support system. Yes, but also I have to consider how many bars you're going to put in, because bars need spacing. That takes a lot of width, right? So if I have a section, right, just give an example, and I'm going to exaggerate today, right? Everything's under microscope, okay? Very huge section like this, okay? A big section like this. Okay, now I'm going to determine the width of it, which I don't know, okay? I'm going to determine the width of it, which I don't know. But I have some requirement. I say I'm going to put down 3 bars at the bottom row and 2 bars on top, okay? And before that, I want to put the stirrups down. So stirrups goes here like this, right? And mind you that it has a curvature, okay? Has a curvature like that, okay? And then go horizontal all the way, almost to the edge of it, and do another semicircle, okay, and then straight, right? So following, if I'm using, say, number 3 stirrups, right? If I'm using number 3 stirrups, so this is 3/8 of diameter, 3/8 of diameter, where I stop right here and do a curve and go straight again, stop here, do a semicircle curve. And sorry about my horrible drawing, okay? I'm doing my best here, so thank you for understanding. And that's the 3 portions. So here I finish my stirrups, okay? It's not that bad. Looks ugly, but not that bad, okay? So that's my stirrups. Now I'm gonna put my bars down. I want to put my bars down, okay? But before I put my bars down, here are some details. Remember I said this is gonna be a semicircle here, right? It's gonna be a semicircle here because that's how I bend my stirrups, right? If you're in person, I would start asking questions. How many of you, have seen a bender before? I don't know how many of you raise your hands up. I actually bend the star, so I've seen the bender before. So when you bend the bar, it comes all straight. You need to force it to circle around a steel pancake, right? Steel disc, right? So the disc has a diameter, and that diameter is what we call a bending radius of the stirrups, okay? Bending radius of the stirrups. And this bending radius of stirrups is 2 times of ds. 2 times of ds. So you may say, what is ds? ds is the effective depth, isn't it? Well, here in this lecture today, ds is the diameter of the stirrups. Is the diameter of the stirrups. Okay, so sorry about the confusion, but running out of names. Okay, so that is the bending radius. Bending radius. You notice that this 2ds start counting from outside edge of the stirrups goes into the center of the bend, to the center of the bend. So naturally, this distance right here is also 2ds. Okay, 2ds. All right, but I'm just gonna take this one out, so make it easy to put my bars in, but this is where it is. To put my bars in, I'm gonna use a red color, okay? To put my bars in, okay? Now, my center, the center of the corner bar, this is the corner bar, okay? The center of the corner bar has to be in line, I'm using cross here, in line with this bending radius center here, okay? And then the bar look like this. And again, sorry for my horrible drawing, okay? It's supposed to be spherical, but looks like elliptical now, okay? Sorry about that. But that is where my bar is gonna be at. And you can see that the center line up with the bending. So there is your contact point. It's the tip of the circle with the turning point of the steroid. That's where it's gonna sit. That's where it's gonna sit. Okay, so that is the corner bar. That is corner bar. Okay, now I would have to put another bar in the middle, say right here. Put another bar in the middle right here and line up the center, of course. Okay, and then I have another bar. And again, forgive my drawings. Okay, I'm trying my best. They're identical bar, but somehow they look not same. Okay, so another bar on the right side corner. Okay, and again, the center bending radius right here, and this is bending radius. This is bending radius. Okay, and again, distance right here is 2ds. All right. Okay, now I want to calculate the width. I want to calculate the width. Okay, and I also know that I'm going to put a second row there. So the second row, the bars should be somewhere here. Let me use it right here, and right here somewhere, say right here. Okay, I'm use dash line just because I want to give more space for drawing it. Here, that is the second row. Okay, second row, and the center of the bars here, center of the bars here. Okay, and I need to determine the effective depth, meaning that I need to determine the center of the group of the bars. And I know that it's going to be in the middle symmetrically in the horizontal direction, but not necessarily in the vertical direction. Okay, that is the center. The triangle is the center of these 5 bars, But, right, before I do anything, let me determine the vertical center first. Okay, so instead of B, let me determine the so-called Y bar. Okay, let me determine Y bar here. Okay, let me determine Y bar here. All right, so I'm gonna make assumption here. I say, you know what, in this case, I'm using all number 9 bars, okay? And now I know dB is 9/8 inch. Area of each bar AS equal to 1 inch squared, okay? So this is each bar, so I'm gonna put a number 9 here just to differentiate, okay? 1 inch squared. So now how I am going to find the center of the group of bars? How am I gonna go do that? So first step, right? First step, find Y bar. Okay, find Y bar. So I need to find the distance between the clear spacing of the vertical bars, So let's just say I have an aggregate size of the egg equal to 3/4 of an inch. Okay, so I'm looking for vertical distance, right? So go back to see the vertical distance that is either larger or 4/3 multiplied the egg. In this case, this is 1 inch. Okay, if this is case 1 inch or 1 inch. So naturally, I'm picking 1 inch here as a clear spacing between the vertical bars. All right, so same thing goes here as the left, right? To calculate this, it becomes easy. So Y bar equal to sigma AI YI divided by sigma AI. Okay, sigma AI. So if this is layer 1, first layer, and this is second layer. Okay, so I'm gonna make a small table here, right? So first layer, which is at the bottom here, right? The area equal to 3" squared, so 3 number 9 bars. Okay, and the distance y, right? Distance y equal to 1.5 inch. So wait a minute, Bob, where's the 1.5 coming from? 1.5 is the clear cover right here. Normal, assume normal exposure, right? Normal exposure. Okay, and plus a diameter of the stirrups. So I'm using number 3 stirrups. Okay, so that is 3/8 of an inch. 3/8 of an inch. Now, this is the distance between the center of the first layer to the edge of the concrete. So I need to add this half size of the bar. So 1/2 of dB, which is 9/8 of an inch. 9/8 of an inch. Okay, and truth to be told, this one calculated to be out of 2.44 inch. To be 2.44 inch. So this is the first layer. Okay, for the second layer, I have 2 number and wait a minute, 2 number 8 bars. Okay, I'm going to use number 8 bars. Okay, just to make things a little bit challenging. Okay, 2 number 8 bars. So I'm having 0.79 inch squared per number 8 bars. Okay, and this to be 1.58 inch squared. Now the distance between the center of number 8 bars, right, to the bottom concrete, right? So essentially is half of dB at number 8 plus is clear spacing of 1 inch, okay, plus half, well actually 1 dB of number 9, okay, and plus ds and plus 1.5. You see, so it's quite a lengthy calculation. So this right here is 2.44, which is whatever I just calculated for first layer, basically right here, right? Add, I can write the other way, add half of dB, so add of 9/8 inch, okay? Add 1 inch, and add half of number 8 bars. So 8/8, that's 1 inch. So this is the distance for the second row, and that is 4.5 inch. Okay. All right, so now I can bring to this equation, so y bar equal to a1 multiplied by y1 plus a2 y2 divided by a1 plus a2, and that gives you a1, so 3 multiplied by 2.44 plus a 1.58 multiplied by 4.5 divided by a1 plus a2 1.58 plus 3. So I got this to be 3.15 inch. 3.15 inch. Okay. Now I'm looking for y bar because I need the depths. Okay. Now normally I would use ds since it conflicts with the diameter of the stars. So I'm going to use d instead. So d equal to h height minus 1 bar. Now I'm going to assume h equal to 24 inches. No reason, right? I'm just going to assume that. So d equal to 24 minus 3.15 inch. So give me an effective depth of 20.85 inch. Okay. Now, you know that to do analysis, I need to know the extreme tensile layer reinforcement, the bottom row, which is H minus Y2. That is 24 minus 2.44. Sorry, this is Y1, okay? Not Y2, Y1. So minus 2.44, and this gives me a 21.56 inch. Okay, so this is how we find the depths of 2 number 8 and 2 number 9 at the bottom here, okay, in this configuration. Okay, all right, so now business is closed with the depths. How about width? How about width, right? So the second step is width. Second step is width. And I'm going to use B minimum because that's a minimum allowable width. Minimum allowable width. So to do this, let me copy this image right here, okay? Copy this image right here. Okay, copy this image right here. Copy and paste it here so you can see it while we're doing it. Okay. Now I don't need a vertical distance anymore because I got all them cleared out. So I'm just gonna erase them. I say I got them vertical distance sorted out. So don't have to worry about it. Yeah. Okay. So pretty good here, pretty good here, here, and so on and so forth, just to get my picture right. So here's straight, and that's where my distance are at, right? First thing first, this symmetric, isn't it? It's symmetric. Okay, so I don't need to find the whole thing. I just need to find half of it. I just need to find half of it. So if I determine half of B, I'm set. I'm set. So how to do that? So let's trace it. So to make it clear, I'm going to use purple color to trace the distance. Okay, all I need to find out is from left end to the right end, what is the half of the width, right? So let's start doing it. So first thing first, this is what? This is the concrete cover, CC, clear cover. Remember, clear cover, which is 1.5. And I have now the diameter of the stirrups, ds. Diameter of the stirrups, ds. Okay, so now from the inside edge of the diameter stirrups, wake up, guys. Okay, this is important now. Okay, from the inside edge of the stirrups to the edge of the corner bar, this distance is a little bit tricky. This distance is a little bit tricky. Okay, let me call this S hat. Okay, let's figure out this distance first. So S hat, right, is the distance between inside of the stirrup to the outside of the edge of the corner bar here. What is that? What is that, right? What is that? That distance is actually what? Is 2ds. Okay, this is 2ds, right? Subtract a ds, right? Then subtract half of bar size. Okay, so this is what it is. So S hat equal to 2ds. Subtract ds, okay? And subtract half of diameter of the bar. Okay, very important, very important. And I know you fall asleep already, but you will be awake during the exam and you will hate yourself for not understanding this if you don't do your job, okay? All right, so that is the spacing between the inside edge of the stirrup to the edge of the corner bar. And then after this point, things are easier. So I just have to count for this whole bar, dB, and clear bar spacing, right? So CS, and then be careful, this is only a half bar. I'm talking about symmetry here, okay? So dB over 2. All right, so theoretically, the half of the minimum beam width, right, should equal to, let's put them down here, CC, okay, plus ds plus S hat, right, and plus dB and plus CS plus dB over 2. dB over 2. Okay, dB over 2. All right, so now what is the clear spacing? What is the clear spacing, right, between the bars? So what is CS first? Right, so here CC I know. So CC equal to 1.5 inch. Normal concrete exposure, fine, cool. What is CS? And go back, right? Go back. We said CS is the concrete clear cover in the horizontal direction. In the horizontal direction, and that is largest of the bar diameter, 1 inch, or 4/3 diag, right? So I'm just going to copy this down here. Say, you know what? It's going to be the largest of diameter of the bar, okay, 1 inch, and 4/3 diag. Now, what is diameter of the bar, right? That is 9/8 inch. What is that? That is 1 inch, right? No need to calculate out. What is 4/3? So 4/3 diag is 3/4 inch. So this is 1 inch. So largest, which one? So this one, dominant. So dB dominance. Okay, so this turns out to be dB. CS equal to dB. Okay. All right. So after I get this figure out, I want to bring all this number in back in here. Okay. So half of the minimum beam width, equal to now 2 ds. Right, sorry. Half of the beam width now CC is 1.5 inch. Okay. And ds is 3/8 because it's number 3 stirrups. Okay, s hat, right? S hat is this fellow right here. So 2 multiplied 3/8, 2ds, minus 3/8, okay, minus half of dB. dB is number 9 here, so 9/8 of an inch. Okay, that is s hat. Now plus dB, 9/8 of an inch. CS, what is CS? Largest, again, dB. And plus, don't forget, half of dB. Half of dB. Okay, all right. So this is only half of the width. And please help me to check this algebra, but what I got essentially is for the minimum beam width is equal to 9.75 inch. Check me afterwards, okay? 9.75 inch. Now, be careful. This is the minimum beam width. So what will be the minimum beam width you want to design? I will try a wholesome number. So let B equal to 10 inch. Okay, let B equal to 10 inch. All right. Okay, all right. So now, ladies and gentlemen, we're done with the section analysis. Section analysis. Okay, so this is pretty good. So I'm gonna stop here, but let me quickly review before I let you go. All right. Now it's very sleepy Thursday afternoon, so I'm gonna cut it short. But starting from the top, what we're trying to do is we're trying to determine the section dimension, right? And then we're going to determine the reinforcement inside. So I said that for a beams, it's mainly determined by the deflection. So right now we're saying is, okay, the height of the beam roughly between L over 18 to L over 12, right? And you can find that from table 9.3.1.1. Right, that's the height. Now for width, we usually line up with the column, but we need to check the details, right? So we need to know the bar spacing and concrete cover. And these are the reasons why we need spacing cover to begin with. And I said it's going to be in exam 1, so pay attention to that. All right. Now we went through some terminologies. There are clear spacing horizontal, there are clear spacing vertical, clear cover on the outside, clear cover on the bottom. Usually these two are normally the same, okay? Usually they're the same, all right? And we went through the equations for them, right? Usually concrete clear covers 1.5 inch. For the clear spacing, horizontal, use this equation. Vertical, use the equation down below. And now we have to be careful with putting the bars, right, in configuration. The bars always putting from outside in, from edge to the center. We went through one example with 2 number 8 bars, 3 number 9 bars at the bottom. Find the vertical center of all the bars. Also find the width of the section by accommodating all the bars with the designated clear cover. Okay, so this is today's lecture. I'm gonna stop here and ready to answer any questions. Folks, anything? If you haven't fallen asleep yet, anything?
I had two
I
questions real quick.
Christopher, maybe you go first. Emily go second. Yeah.
For the second layer of bars, do they not have to be touching the stirrups?
No, they don't have to. Theoretically,
Okay.
they don't have to. But to be honest with you, when I was tying the bars, usually you don't really worry that much. If you can just tie it, you're fine. And if
Okay.
you really want to be lined up with the bottom row, usually you can put a plastic chair like this, but that's very rare.
Okay, and then for the S hat,
Hmm.
would it also work if we did the clear cover plus the 2DS that you had from the outside of the stirrup
Yes.
to the
Yes.
center of the bar?
That is correct. And you may ask why bother going the long way, right? Reason is that sometimes engineers will require you to know the spacing here. So you know that whether you can accommodate the bars or not.
Okay, thank you.
Yeah, no problem. So Emily, you're next.
Oh, I was just wondering when you post the notes because I missed a few things here and there, and I just wanted to
I
go through the notes
oftentimes,
after.
sure, I oftentimes post a note right after. So if you
Okay,
check on
thank you.
Canvas right now, you should have seen note from 1 to 4 there. If not, just email me, okay?
All right, thank you.
Yeah, no problem. Anything else, folks? This is very important stuff, okay? You need this. And if you say anything wrong on the job site, you'll be left out by the construction folks, okay? So anything for this?
Can you scroll down to the bottom with the B-min?
Yes, sir. Is this okay, Kyle?
Yeah, it's fine. I'm just double checking my numbers. I ended up finding it to be 9, but I'm double checking that I wrote down everything right.
Sure.
I
Let
also,
me know.
I also came up with 9.
You also got 9, right?
Yeah.
So let me see if I make a mistake somewhere here. Allow me to double check it. I may have made a mistake. I cannot tell you right now. Allow me to double check, and I'll get back to you with the correct notes uploaded to Canvas. Is that okay?
Yeah, that's fine.
Yeah. Thanks. Okay. Anything else? I double checked the number. Pretty sure I did right, but anyway. Anything else, folks? Okay. If nothing else, I'm gonna check my number to make sure that's right, and I'll upload the correct notes after I check that. And homework number 2 is due tonight, midnight. Okay. Haven't done that. If you haven't done that, please hurry up. If you have any question for me, ask and stay behind the class. Okay. Other than that, I think we're good. I'm gonna stop recording and see you on Monday. Okay.